Lab exercise on demand estimation and forecast. Problem number 1. Ivermectin Pharmaceuticals sells and delivers vaccines for COVID-19 and other antidote medicines to its target market. The vaccine and antidote supply venture is competitive, and the ability to deliver orders is a huge factor in getting new customers and sustaining the old ones. The company manager wants to be sure that enough drivers and vehicles are available for deliver orders promptly and that they have sufficient quantity of inventory. From the records of previous orders, management has accumulated the following data for the past 10 months. Compute the monthly demand forecast for February through November using the naive method. B. Compute the monthly demand forecast for April through November using a 3-month moving average. C. Compute the monthly demand forecast for June through November using a 5-month moving average. D. Compute the monthly demand forecast for April through November using a 3-month weighted moving average using weights of 0.5, 0.33, and 0.17 with the heavier weights on the more recent months. E. Use the following table as guide in the presentation of your forecast. Solutions. A. The naive method simply uses the demand for the current month as the forecast for the next month. So, the forecast time plus 1 is equals to demand time. So, for February, we will have forecast on February equals to demand on January. So, it equals to 1,200. Similarly, to forecast to November, it equals to the demand of October is equals to 900. So, you can see the table below for the other months. B. So, for a simple 3-month moving average, we take the average of the previous 3 months demand as our forecast for the next month. So, the forecast time plus 1 equals to demand time plus demand time minus 1 plus demand time minus 2 divided by 3. So, since we need at least 3 months to compute the average and we only have data beginning in January, April is the earliest month for which we can compute the forecast. So, for the forecast for April is equals to the demand on March plus the demand on February plus the demand on January divide by 3 is equals to 1,000 plus 900 plus 1,200 is equals to 3. Divide by 3 is equals to 1,033.33. So, the forecast for the other months are reported in the table below. C. The 5-month moving average is similar to the 3-month moving average, except now we take the average of the previous 5 months demand. We start with the forecast for June, since we need at least 5 months worth of previous demand. So, the forecast for June is equals to the demand in May plus demand in April plus demand on March plus demand on February plus demand on January is divided by 5. So, the computation will be 1,100 plus 750 plus 1,000 plus 900 plus 1,200 divided by 5. So, is equals to 990. So, the forecast for the remaining months are computed similarly and the values are reported in the table below. D. So, the simple moving average like parts B and C above place an equal weight on all of the previous months. So, a weighted moving average allows us to put more weight on the more recent data. For a weighted 3-month moving average, we have forecast time plus 1 is equals to then note that the weight should add notes that the weight should add up to 1. So, using the weights specified in the question, the forecast for April is computed as forecast for April is equals to 0.5 times demand on March plus 0.33 demand on February plus 0.17 times demand on January. So, the computation will be 0.5 times 1,000 plus 0.33 times 900 plus 0.17 times 1,200 and equals to 1,001. So the forecast for May through November are reported in the table below. Problem number 2. So the following data shows the amount of unit sales and corresponding profits of AstraZeneca, a distributor of multivitamins and other food supplements for all ages. So this is the table. So the answer for this is A is determine the least square regression equation. So the y is 0.0175x plus 2,621.9. The slope is 0.0175 and the intercept is 2,621.9. So the forecast, so the profit will be earned if AstraZeneca unit sales is at 7,200. So the y is equals to 0.01775x plus 2,621.9. Y is 0.175 times 7,200 plus 2,621.9 is equals to the forecast for the forecast will be 2,747.9. So you can see on the graph how did we get the square regression by doing an Excel. Problem number 3. So make a research on how car companies estimate the forecast and forecast the quantity of cars that they will have to manufacture. What forecasting method do they adopt relative to their manufacturing concern?